Alright, so the concept 1 of chapter 5. So what is a moment? Moment is a force. Of a force is the product of the force. Okay, and the perpendicular distance from the force to the pivot in order to produce a turning effect. Okay, so the formula is F times D, where F is your force and D is the distance, or to be more specific, perpendicular distance. Okay, alright, so our force have a unit of Newton, distance have a unit of meter. So my moment has a unit of Newton meter. Alright, okay, so let us take a look. What do I mean by the product of the force and the perpendicular distance using this diagram? Okay, so I have a force of 5 Newton here and a plank. Okay, this plank is about maybe 4 meter long, and we have a pivot here, right? Okay, so if you notice, I'm using the product. I'm multiplying 5 and 2. Okay, so the distance and the force must be perpendicular to one another. So that's called a moment. Alright, okay, so moment is equal to 5 times 2, which is equal to 10 Newton meter. Alright, and of course we must state the direction because it's rotating, right? So I must state the direction of the rotation. So if you see, this is a clockwise direction. Okay, yeah. So what about the second diagram? Second diagram, we have a 4 Newton and a 6 meter balance beam. So the pivot is exactly at the center. Okay, so the moment is 4 multiplied by 3. Okay, and there's a perpendicular distance, right? So 4 multiplied by 3, you get 12 Newton meter. And yet, if you look at the rotation, the direction of rotation about the pivot is in this direction, right? So this is anti-clockwise direction. Alright, okay. So the last case is this case. Okay, so I have a plank, but the pivot is at this particular point. Okay, and the force is here, and we are given the length of this so-called beam, okay, of 5 meter. So why is there no perpendicular distance? Why is there no moment? Because there's no perpendicular distance to speak of. Alright, maybe let's go back to the clockwise moment. So how do I determine the perpendicular distance? First of all, you must have a force. Okay, second of all, you must have a pivot, and this pivot, maybe you can put a dotted line here. Alright, then you from the force to the red color line, you calculate what is the length. Okay, you calculate what's the length. So your force is downwards. Okay, so your perpendicular distance must be perpendicular to the downward force. Okay, so this is the perpendicular distance. And when you reaches this red dotted line, you must stop. Okay, you start from the force, you end at the red dotted line. Okay, so this will be 2 meter. Okay, so likewise for your anti-clockwise moment, you have a dotted line and you have a force also downwards. So the perpendicular distance must be from the force to the red dotted line, which is 3 meter. Okay, but what about this no moment? Okay, no moment, you draw a dotted line. Okay, and you draw the perpendicular distance from the force to the red dotted line. You notice that I do not have any perpendicular distance. Okay, this 5 meter is what we call the parallel distance. Okay, because perpendicular distance should be in this particular direction. Okay, yeah, right. So another scenario is this. I have a pivot and I apply the force exactly at the pivot. Right. So at this case, you will not have any turning effect. Yeah. Alright. So you need to determine, in order to determine whether there's a moment or not, you need to determine, is there any perpendicular distance? Normally the force will be given. Yeah. But is there any perpendicular distance? Right. Okay. Alright. So checkpoint 1. So we have a lamina suspended from point P. So point P is our pivot. So we have a weight. The weight of the lamina is about 2 Newton, and the center of gravity is at C. So basically, this is your 2 Newton. Okay, so what is the moment about P due to the weight of the lamina? Okay, so remember, in order to find the moment, you need to, of course, you need the force, you need the perpendicular distance. The force is 2, okay, but what is the perpendicular distance? The perpendicular distance must be from the force until Q. Okay, so this will be the perpendicular distance. The P is your pivot. So to determine your so-called perpendicular distance, maybe you can draw a purple line here, and you start to draw your perpendicular distance from the force to the purple line, stop it. Alright, okay, so 2 times your QC, right? So QC, we are given that this is about 0.3. Alright, so the moment is about 0.6 Newton meter. Yeah, but this is not enough because I need to state whether is it clockwise or anti-clockwise. Alright, so as you can see, this is definitely a clockwise direction. Alright, so answer should be A. Right, so let's move on to checkpoint 2. Okay, so this is an open structured question. We are given 3 scenarios where the same vertical force of 200 Newton exerted by the cyclist in a different position A, B, C. So state the position A, B, or C in which the force exerts the largest moment about the pivot. And I need to, of course, give my reason for the answer. Alright, so this type of qualitative question where you just need to explain. Whenever you are doing a qualitative question, please look at the number of marks provided. Then you give your points accordingly. Alright. Okay, so definitely the largest moment is KC, right? Okay, why is it KC? The force exerted are the same. Okay, just that the perpendicular distance is different for each of the scenario. Okay, so let's take a look at A, scenario A, right? We have a pivot here. Okay, if I draw a line, here, okay, so there's a force here, right? Okay, there's a force of 200 Newton here. So what is the perpendicular distance from the red arrow to the purple arrow? Okay, so you can see that there's no perpendicular distance. So the moment is equal to 0. Alright, okay, for B, if you look at B, the pivot is right here. Okay, and if you notice that from the force to your red line, right, red dotted line, the distance is, there's some perpendicular distance, just that the perpendicular distance is not so big. Okay, so maybe you just put 1 meter here. Alright, okay, so take a look at case C. Case C is there's a pivot here, and there's a force, right? You notice that the 200 Newton to the blue color line, the distance is definitely bigger. It's about maybe 2 meter. Okay, so the moment, the largest moment is your KC, right? And okay, so the moment for this KC is the largest because, okay, largest moment because it's due to the large perpendicular distance. Right? Yeah, so this is for the checkpoint 2. Right?